Tesla has shown themselves again and again as leaders in manufacturing. The way their vehicles are made are industry leading, and auto experts often find surprises as they tear the cars down to study them. Today, we'll watch a video from Sandy Munro as he shows how the Cybertruck, for example, has revealed a number of Easter eggs and surprises. It's an absolute work of genius. Some critics are claiming that the new steer-by-wire system is dangerous, but actually, it's triple redundant. We'll also watch a fantastic video from Autoline Network where they did a detailed tour inside the Cybertruck, paying particular attention to the battery pack. But what was really cool was they discovered how Tesla has future-proofed the Cybertruck and the future potential for wireless inductive charging. This is ready for robotaxi. And so the perfect person to have with us today is Jeff Lutz. He is a chief supply chain officer, but he also was in charge of manufacturing factories. This is the kind of jobs you have been doing, both in your consulting work as well, right, Jeff?
Yeah, when I see the work that Sandy and Terry at Caresoft do, their prior roles, we speak for Terry, is very similar to what I was doing inside of a company at various levels, but really responsible for the integration of how a product is going to be made. It's designed for manufacturability, and then the plan to actually scale it inside of a supply base and inside of your four walls of manufacturing, and then getting it out to endpoints of distribution. So what these gentlemen are doing, they're both very intelligent, by the way. They understand when they're going through teardowns, you should watch their videos, because they're not speaking to it in kind of like passive, like surface terms. They really understand why some of these decisions were made, and they're giving you insights that you wouldn't get by just looking at your vehicle or looking at some parts laying on a table. So I love these videos, and I really respect what these gentlemen and the teams behind them are doing. So I think that it's going to be fun for viewers, because we're going to be able to unpack a couple of things that you may not have been aware of as we go through a series of these videos.
I love it. Thank you for preparing this for us, Jeff. He took 6 clips, right? So 2 from Sandy Munro's. We're going to watch 4 very short clips from Autoline, just the most important parts that actually explain, a lot about the way that Tesla builds the cars. The first one from the president of Caresoft, very similar to Sandy Munro's group that they tear down these cars. Terry Wachowski is the president, and he talks about the ease of automation. Let's watch that.
Tesla has a unique approach when they, from a charging perspective. Typically, these harnesses would be made of copper, and they would be flexible, and it would be a little bit like wrestling an anaconda. They are heavy, and they are, tough to negotiate. But Tesla's made theirs out of aluminum, so it's actually an aluminum conductive rod. There's an insulator over it, and then there's a protective sleeve, aluminum sleeve over that, and then a coating here, just from standard perspective, so don't cut here. This is the high end.
Don't cut here in case EMS has got to get into the vehicle.
First responders, extrication, and that type of thing. So if you see this orange stuff, best not to cut.
Don't touch it.
Don't touch it. This mounts here. Mm-hmm. Now, because it's a solid part, it can even be automated. I mean, it really is a pretty good way to attach these.
Go ahead, Jeff.
So Herbert, what I liked about this was, number one, the call out on the materials for that cable. Tesla has their own materials division where they work on these actual, not only the actual end product itself, but the actual substrates and how these materials are actually made. So on the metallurgy side, going with that aluminum substrate, both from a cost perspective, as well as they got the rigidity. And the rigidity that they wanted in this case, number one, is for strength, and you want something that's going to perform well in various environments and vibration and load. But the other piece of it is the other piece around that is the ability for automation. That's what Terry was bringing up at the end. So if this thing was just kind of like flopping around, that would be a very difficult thing, and it'd have to be done by a human, maybe eventually a humanoid, but definitely by a human. But the fact that they were able to get that assembly to be rigid, this is something that could be literally picked up by a robot and then placed into the vehicle. So I think it was really important to call that out because there's kind of a ramp that can occur both from a materials perspective and a labor perspective to make that whole assembly reduced in cost. And what we were looking at when he was putting that in, that was basically the bottom side of the Cybertruck, and I believe that was a connection between the battery and the motor inverter. So very important high voltage, high current connection. Why don't we go to the next clip?
Yeah, let's go to the next clip. And this is actually explains why possibly the Cybertruck was delayed. So this is very interesting.
Different from the Model Y, we see application of a lot more fuses. So I don't know if that was lessons learned along the way or because this is an 800 volt beast. I think a lot of this comes down to the fact that this water wading mode, this boat mode, I think that was a bear. I think that was really bad. Really difficult challenge engineering-wise. So now we have more protection, more fuses. In fact, this fuse, it's in a gummy kind of a potting. It's actually kind of sticky.
Oh yeah.
Yeah, that's for the AC
That's
compressor.
weird. I mean, it's like glue.
It's like
almost.
glue, like undried glue. Also, you notice that there's this interesting potting material that has come around.
It looks like putty.
It looks like putty. I think kind of is like putty.
Yeah.
And I wouldn't be at all surprised if that didn't come in late in production because they said, oh, we've got some water intrusion, we have some problems. There are actually 4 water drains in this penthouse. So if water does enter that, we've got in the 4 corners, there are drains. And the way they're made is that when they're exposed to water, they swell, they change, and they pop this open, lets water out.
Huh. Let's get that for the camera view too.
So the penthouse has 4 of these in. You see this, which may have been evidence that they had some water intrusion. And then interesting, when you look at the top of the battery box,
This is the top of the penthouse.
The top of the penthouse, we see this insulating material over here.
This yellowish orange stuff.
And that's like, well, why is that there? Well, I don't know, other than I can speculate. There was some sparking going on. There was some witness that water was in.
Wow, that is so cool. They discovered that by tearing it down. They saw that there was a putty that they had to then start adding, I guess.
Yeah. So
Very
when you're
cool.
dealing with liquid ingress, it's one of the toughest things to deal with in product design. But you have to understand how your consumers are going to use the vehicle or use the product, and you have to be ready for that. And what I see with the potty material, the putty, what I see with the that yellow tape is called Kapton tape. It's a very thin, non-conductive tape. Basically, if you have 2 things that could potentially that are not supposed to touch, but have a 1 in 1 million chance of potentially touching or less in the design, you'd want to put that in as an insulating layer to protect from that, and it does the job. So what I saw from all those things, that was indicative of all the drive testing that they were doing on Cybertrucks. All the Cybertrucks we saw on the road for a year prior to production. My guess is what they were doing is, number one, they were probably experiencing full-on battery failure, but eventually they cleaned up all those issues. And then what they were doing is they were drive testing these trucks after a couple of months, even with no failure. They would pull, my guess is they would pull the pack out and then look for inspections for any liquid ingress. They were probably also doing something called an LDL label. They were actually putting liquid detect labels inside of the vehicle that change color. Now, sometimes these are used in production as a means of dealing with warranty with a consumer abuse, but they can also be used during the product development process to paste these labels at various points to understand if you're actually getting liquid ingress in a place that you're not supposed to have liquid ingress. The other thing you can do is visually look for signs of corrosion, but that takes a period of time, and you would need electrical current involved to really start seeing a lot of that corrosion soon. So the whole liquid ingress management is what Terry's get to. That's usually in any product design. If you have a very steep standard that you're trying to get to, or maybe in the case of the Cybertruck that this may have entered in as a later requirement, I kind of agree with him. This could have been, it's not important, by the way, but it could have been one of the things that definitely delayed the product from, the ability to finish the design and start ramping. But once they figured this out, my guess is this battery pack for normal use, normal consumer use, is going to be one of the most robust battery pack designs for normal use out there. I mean, this thing looks like it was really engineered well, and it's engineered to deal with all these different liquid ingress challenges and to be able to actively deal with them, and actually expel the water. So I was fascinated by the design and fascinated by their approach, and kind of agree that this could have been one of the things that really stretched the design out a bit. But once they solved it, they've got a better product.
That's a simple solve too. So it's, you have to discover the issues, solve it, and then maybe rebuild it in the future. But very impressive. This next bit is interesting new additions of castings. Let's watch this one.
This thing here you're talking about. This.
Yep. That was inboard with the console and then the outboard pieces.
A lot of stamping, a lot of welding, a lot of little pieces to all this.
Then in 2021, and I say that a little tongue-in-cheek because model year and Tesla don't exactly go together, but this is when at the Model Y, the floor disappeared in the body in white, and the top of the battery became the floor of the car. And then they mounted the seat directly to the top of the battery. So they did it in this fashion, to get more integration, more efficiency. And so these seats are attached to this battery. When it comes in place, seats are gone.
Real smart move. It really simplifies assembly.
Now with the Cybertruck, taking it another step, so this progression that we're always seeing, there's some evolution in Tesla. Now that structure is a casting.
Very interesting. So one piece, not all these stampings, not all this welding.
One piece.
I mean, this company loves castings.
Yeah. And it'll just come over and it will locate. It's got a locating pin. And so it will locate, and then these holes will be lined up, and you can just drive these fasteners in.
Right in. Yeah.
So it's all that's gone, all those multiple pieces and all that. So this casting is continually evolving to new and more places. And when we get to the body in white, you'll see it quite a bit.
Jeff, this is why when you've been telling people that, as the months go by, as the quarters go by, as the years go by, Tesla could still possibly find ways to reduce cost of goods. People don't believe you. They stop forecasting it. You already sold voice that says, but they might still be able to find something. These are the things that might still happen, right?
Yeah, I mean, let's talk about it. So those castings under the seat are strong. In terms of its total volume, they're usually stronger than the welded version that they're replacing. So they're greater in strength. And then the actual the material properties of the metal itself versus the welded version, they're less in weight. And then the actual welds add weight to the product as well. And of course, they had processing time. Of course, they had CapEx to do all those welds, and people and CapEx involved to do all that. So that all gets eliminated with the casting. So you've got a lighter, stronger piece. So if you take the weight out, as you take mass out, then you're in terms of your battery efficiency, it's improving. So all these things are connected together, and they can either extend the range of the vehicle, or they can actually reduce the size of the pack, but if it's a new product before release. So I just love that example. It's just showing how Tesla's involved. And they take it in stages, and people think like Tesla's just rolling stuff in and kind of willy-nilly. No, this is very smart approach of, okay, stage one is we're going to connect the battery pack floor to the seat. We're going to have this structural version of the product. Now others are copying that. Okay, but the connection scheme is going to be this welded, intermediate piece with a bunch of different parts together, and then they're going to take that piece and then they improve it dramatically, make it a casted piece, get rid of all the welds, get rid of all the additional parts. So now you've got a part count that may be in the area of 12 to 16. That's down to 1 or 2, and that complexity reduction. There's mass reduction in the car. Then there's 80 or 90% less material for someone to actually go source and purchase. And then there's less opportunity for excess and obsolescence because you have less components. You need less space in the warehouse to store material. All these things add up. You don't need the CapEx on the line. So all these things add up. It just shows the progression of how Tesla is, continuously driving improvement in reducing complexity and cost.
Wonderful. Thanks, Jeff. So this next part is an Easter egg. This is preparation for robotaxi. So let's watch this. This is exciting. This is the one that got you so excited. I saw you giddy up when you watched this one.
This is a dream. This is the range extender. And so there's been talk about, hey, if you want more range on your Cybertruck, we're going to give you another battery, auxiliary battery, that will mount inside the pickup box.
Almost looks like a toolbox in the back of the bed, right?
And if that comes to be, when it comes to be, this is where it would attach. So it's engineered for it, it's ready for it. Now when that box will be ready, it would be up to Tesla. But if it does, then cabling would go from that auxiliary box, pass through the floor, and connect here. Just like we had the front E-drive, we have the rear E-drive, so we're sending power to both. This is the connector just for the AC compressor. I don't know if you've ever tried to turn an AC compressor by hand, but it takes a lot of power, and so we send that out. And there's also been talk about an inductive charger that Tesla has been teasing. We're going to come forward with an inductive charger, a mat. You simply drive over. There's probably some targeting in your HMI screen, and you, I'm right over it, stop. And then inductively it'll charge. If you were to get that, a device would plug in here. So this would be able to...
So they've obviously planned ahead.
It's planned, this is planned, it's there, this is planned, it's there. When the other piece comes together would depend on their engineering validation.
Smart.
So this is inductive charging, which is the car can just go over a mat, and then you can get wireless charging. Sets you up for robotaxi. It sets you up for just ease. You don't have to plug in your car to get batteries. They didn't roll this out yet. They haven't announced it yet, but it's planned. There's all these things that are built in, can come in the future. Pretty cool.
Yeah, I like the design. And so Tesla is shipping right now, looks like then a connector in your vehicle and some sort of wiring assembly to the battery. And then most of the direct material costs would come in the form of the receiver for the inductive charging that would have to be placed under the vehicle and be a kind of a coil pattern. And then you would have the transmitter and the mat. And I guess I guess there's multiple ways to do that, or multiple configurations of it. But the point is they've put in the provision for inductive charging that got me pretty excited. And they did it in a very smart way. And it's super modular for them to basically add this capability onto the vehicle at a later point in time. And of course they can update their charging stations, thereafter. So I like the fact that they're thinking about it. I like the fact that it's a reality. And I like the fact that teardowns can actually reveal some of these things coming. To me, that's super exciting to be able to see these things and see them revealed in a teardown.
Okay, let's get to Sandy Munro. He's obviously the teardown titan. He is amazing. We're going to watch his video that he did. And you've been saying that I think Dan O'Dowd and a lot of other people have been just attacking, right? Attacking Tesla, saying that the steer-by-wire system that Cybertruck has is very dangerous. So let's take a look at what Sandy Munro has found. I'm going to split this into two short
Switch
clips.
gears here.
Yeah.
One is pure steer-by-wire, and the steer-by-wire system here is what we call triple redundancy. Same as what you'd find in an airplane or a jet aircraft, like a fighter or something like that. Steer-by-wire is what they use on ships, airplanes, pretty much everything imaginable except cars, except for this one. So today what we're going to do is we're going to give you a brief introduction into steer-by-wire. And I'm going to go in and turn the wheels, and Armin's going to tell you what's going on. Apart from the fact that the wheels are moving.
The wheels are going to move.
Yeah, the wheels moved. Okay, so. Okay, Armin, you're on.
So if you come here, Sandy is inputting steering angle on the steering wheel, and without it being mechanically connected to the front axle, we're electrically producing steering angle at the wheels as well as in the rear. So if Sandy is wiggling back and forth the steering wheel, we're seeing that all 4 wheels are steering without any mechanical connections, right?
This is the video that they did. I highly encourage people to check out Munro Live, Tesla Cybertruck steer-by-wire system. That was just one of the short clips. Thoughts on that, Jeff?
Yeah, and we can get to the next clip in a second. It's just Sandy here introduces the point, and there's been a lot of debate about doing steer-by-wire in a vehicle. And remember at Tesla, what they say, safety is the most important thing, and they spend the money on it. You're going to see in this next clip physically a triple redundant steer-by-wire system, which is basically comparing the signals that you're giving it and making sure that the actual end operation is being executed. And if if path 1 fails, there's an alternate path, and even there's a third path, and it's also checking for consistency. So let's watch this next clip. And I just think there's been some conversation about this, and like, oh, we need to look into this. Is this safe and so forth? And Tesla took an extremely safe, and they have triple redundancy in this system is kind of the key takeaway. And I love the fact that we can actually see what they're doing in this next clip.
But you will notice that the Ethernet loop is doubled because everything has to have at least double redundancy.
Yep.
But Armin's going to tell you about the triple redundancy that we've got with the steering motors.
Yeah, so you take that signal and you send it to your steering rack, right? And on the rack we have 2 motors for redundancy. So if one fails, you still have a backup, right? And 3 sensors, 2 integrated into these units, and a tiebreaker in case these sense a different situation going on. You have a third one to
Give the tie-breaking rule for what you're going to be doing next, or what the electric motors that are steering the car are going to do next.
Right. So that this is a triple redundant system.
Yeah.
The insides are beautiful. And it reminds me of Steve Jobs, where he said that, if you're building a fence, the back of the fence has to look good as well, even though no one's going to see it. But it's not about beauty. It's about just precision, and just it looks gorgeous inside. Yeah.
Yeah, absolutely. Very simplistic, streamlined approach. And Tesla does some pretty cool markings too on a lot of their parts that they do custom. But yeah, the key takeaway, and even Sandy introduced in the beginning of the video, even the on the 48 volt, there's redundancy on that bus as well, in that loop inside of the vehicle. So you've got redundancy there, and then you've got triple redundancy with steer-by-wire. And if one of those motors were to fail, I guarantee you that that message is being sent to the main computer in the vehicle, and that that vehicle would have to go in for repair. They're not going to just let you drive endlessly with one of the motors out. So there's redundancy there in terms of action. There's also redundancy there in terms of decision making. And I like the way that Tesla did this. And these are how you build systems where you never hear about a failure that's related to the design of the vehicle. Usually there's some other catastrophic event involved. So this is revolutionary for automobiles. It's been in planes for a long time, but to be able to get this into automobiles and do it the right way, and do it in a cost-effective manner, I guarantee you Tesla is not going to reduce the redundancy of this system as a cost reduction manner. They'll simplify in other areas. They may simplify this system, but having that triple redundancy was designed in. And I'm sure at the end of that, on that whiteboard, they're trying to figure out, like, how do I get this, so it's greater than 1 in 100 million, or something on the order, some large order of the probability of failure being very, very minute. So I think it was just great to see this, and I love the way that Sandy and the team get to these key details in their teardowns and lay it out in plain English for consumers of the information.
This is the role that you played in this case, mobile phone industry, where you were the chief quality officer, high level executive for quality. So you would tear down your own devices, make sure that the factories are building it correctly. You've done this. This is the jobs that you've been following.
We did it for supply, and reliability. Yeah. So on the supply side, we're trying to understand from a cost perspective what they're doing. And I think, Terry and Sandy are doing that as well, but they're also looking at it from a reliability perspective, which is, how do they design this thing, and how do you couple the cost piece and the quality piece together, and like what's the probability of failure, and why do they make these decisions? So when you're doing a teardown, you are looking at like why do they make these decisions from a design perspective? Why do they make them from a cost perspective? Why do they make them from a quality or a supply perspective? And you try to reason through all these things. Then you try to understand what is the actual material, what's the actual assembly method, and what would it cost if we were to actually build this product? And that's what you try to do in a teardown. And in their individual companies, for these two gentlemen, that's what they're doing. They're selling this information, and they're helping advise other companies. Other companies, you either have this capability inside of your company, or you have to go out and buy the information. And sometimes when you go out and buy the information, some of these practitioners aren't as good or as detailed. But the fact that, Sandy and Terry, they come from the industry that they're actually serving, gives it a lot of credibility. So I would definitely be listening to what these gentlemen say, and I think they're super helpful in instructional videos.
Yeah, thank you for pointing them out. And we pulled 4 short clips from the Autoline video. We did 2 from the Cybertruck steer-by-wire, and lots of great information, just a short show here. Thank you, Jeff. Follow him on X at the Jeff Lutz. Thanks, everybody. Bye-bye.
Thank you.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.